Hello students, this is lab number 3. We are trying to verify Ohm's law. Ohm's law is basically the relation between voltage, current and resistance. And according to Ohm's law, voltage is the product of current and resistance. That is what we are trying to check. So here is the circuit that we need to connect. For that, the circuit should be connected exactly as shown here. Let's go to the circuit and see if you can see that. So you see that the positive of the battery here is connected by a wire to one end of the switch. That's a switch. That's SW1. From SW2, a wire is taken and connected to one end of the potentiometer. I think that's called P1. And from P2, the wire is connected to this end. Okay, connected to this end there. That is S4. And from C4, you have this resistance connected. The resistance here that I'm using is 10 ohms. You can use smaller values to get more accurate results here. That is the resistance connected between C4 and C8. And then from S8, you connect the wireless current sensor. So that's the current sensor. Hope you can see it there. That current sensor. Make sure that the positive of the current sensor is connected to S8 and the negative of the current sensor is connected to the negative of the battery. Negative of the battery. Then take the voltage sensor and the voltage sensor is connected across the resistance. So the positive is connected to J4 and the negative is connected to J8. So you see the voltage sensor is connected in parallel to the resistance, while the ammeter is connected, the current sensor, that's the ammeter, is connected in series. So those are the connections in the circuit. So obviously the current flows through the path from the positive of the battery through this wire. You got to keep the switch pressed down, remember that, and then it goes through the switch into this, and from there through the potentiometer. Now the potentiometer is used to change the voltage. That's why it's called potentiometer. Potential difference is another word for voltage. So that's used to change the voltage. When you turn this knob, you can change the voltage. So initially, make sure that the potentiometer is turned all the way clockwise and kept to one end, at one end. Okay, and then it flows through this, and then through the resistance, and through the current sensor, the circuit is completed. So as usual, you go to the hardware setup and add the sensors. And here is the current sensor and the voltage sensor both added. Just one thing you got to do is go to the settings of the current sensor and put a check mark where it says 0 sensor measurements at start. Okay? And hit OK. Do the same thing for the voltage sensor. So put a check mark on where it says 0 sensor measurements at start and hit OK. After you have done that, click on the hardware setup to hide it, and we're going to actually take the classic templates and we will go with this second one and select measurement. First pick voltage, and on the other side pick current, and on the y-axis again pick voltage, and on the x-axis change the time to current. So you got it all. Another very important thing is you got to go, we're going to use the continuous mode, and then keep mode. Okay? And after you've done that, make sure the potentiometer is turned clockwise, all the way clockwise, right? And then remember, the potentiometer is used to change voltages. So for each voltage, we're going to measure the current. So what you do now is keep the switch pressed down, hit preview, and there is the reading, and hit keep sample. Let go of the switch, turn the potentiometer counterclockwise just a little bit, press the switch, the readings are there. When it stabilizes, hit keep sample again. So you get the second point. You see how the graph is being drawn? Turn the potentiometer a little bit more counterclockwise, press the switch, let it stabilize, keep sample. There you get the third point. Again, repeat this for several measurements. Keep the sample, let go, and you get your points. Turn the potentiometer, press the switch down, and keep sample. All right, keep going. One more. Press the switch, keep the sample. There it is. And then still going. All right, so maybe the last one. Now I've come to the end of it. Press the switch, keep the sample. There you have it. So now you can see that for each value of voltage, the current was changing, and you have a lovely graph here. Now you may hit stop because we're going to work with the graph, and then you can find the slope of the graph. The slope of the voltage current graph is going to give us resistance, because we have taken voltage on the y-axis and current on the x-axis, and voltage divided by current gives resistance. So to find the slope of the graph, we can just zoom in a little bit on both axes like that. All right, and then go to the slope tool. Since it's a straight line, we can just go directly to the slope tool, this one, and click on that, drag this, drag this onto that point, and there you have it. The slope is 9.952 volt per ampere, which is actually ohm. So that is how you get the value of the resistance. And in this way, you have to do it for all the other resistors. So that is part 1 of the lab. All right, so in part 2, we have 3 resistors connected in series, as I'm going to show you in a bit. And the current flowing through all 3 resistors are the same because they are connected in series. So this is a case where the current is a constant. And we're going to measure the voltage across many combinations. First, we will record the voltage across across each of the 3 resistors. Then we will measure across combinations, as I am going to show you. So let's go there. So here is the circuit now connected, as you can see. You have the 3 resistors, 1, 2, and 3 resistors, all connected in series. The ammeter is connected between these 2 points, and the voltmeter can be moved from one point to the other, so we can measure the voltage at different points. But right now it's connected across R1, across this one. Okay, make sure that the positive is always on this side, right side, and the negative is on the left side. So if the voltmeter is connected across these 2 points, then we are measuring the voltage across R1. But if we connect it here, and I've not moved the negative, then you're measuring the voltage across the combination of R1 and R2. And if you move it here you're measuring the voltage across the combination of all three of them. So you're getting the voltage across all three of them. So that's how we can move it to different points. So on the other hand, if you take this and connect it here, now I moved the negative, you are now getting the voltage across the combination of R2 and R3. So I hope that makes sense. Now I'm going to show you how to set up the capstone so you can measure the voltages, because the current is the same. I'm going to add a new page, add page, and what we need is, we need 3 of this. So pick that and then click on this and add digits. And for measurement, we're going to be measuring the voltage. So that's what we need. We just need the voltage. Okay. And here we can actually take a table. Now in the table, first measurement is going to be voltage, and the second we're going to create new and user entered data, because we're not measuring resistance, we actually need to enter it. So let's say resistance, and you can also change the unit to ohm or ohms. So we have that, so we have to manually enter that. And then we can take a graph. So the third one is a graph, where you take the graph between voltage on the y-axis and resistance, this, because you see the small r here, so that corresponds to that. So that's how you set it up. So I'm just going to show you one of the measurements. Right now it's the voltmeter is hooked up across R1, and remember to keep the switch pressed down, and let us see what the voltage measurement is. So you got to hit record here or hit the continuous mode and keep mode. Okay, now it's reading 0.212 volt. So if we hit keep sample, that will stay there, right? And the value of the resistance we have to measure using the multimeter. So you can hook this up, take the multimeter, you got to put it on the resistance one. We can use the 200 ohms, and then put the terminals across. Be careful, put the terminals across these two because it's between these 2 points. So we're going to measure the resistance between these 2 points. That gives 20 ohms. So I think you can see that it's 20 ohms. Okay, so you measure the resistance like that, and once you get the resistance there, you enter it into the table. So that is 20 ohms. Okay, hit enter. Then I'm going to measure the voltage across. This is just an example. You got to do everything looking at the table, but I'm just showing it across all 3 now in series. So the current doesn't change. Now press this down again, and it's 0.837. So keep sample. Now what is the resistance? Let's measure the resistance again. Turn this off, so put it back on 200. Now you got to hook this between these 2 points. So yeah, you got to do that, and it's showing 52.6 ohms. Okay, 52.7, 52.6 or 52.7. So enter that. That is 52.7. So let me show you one more. So you got to do all of those combinations, and actually you have to measure the voltage across R1, R2, R3 individually, then across R1 and R2, then across R2 and R3, and then across R1, R2, R3. That is what is given, so you got to measure that. So you see, this is what I've been trying to tell you. So you got to measure the voltage across R1, across R2, across R3, then across R1 and R2, then across R2 and R3, and then across R1, R2, R3. So 6 times. Each time you will move the voltmeter and the multimeter between those 2 points, like I showed you for 2. And each time you get the measured voltage. Let me just take one more combination. I just want to take between, let's say, R2 and R3, right? We didn't do that. So let's move this to R2. And this is on R3. So that's between R2 and R3. And let's press the switch down. Oh, now you don't see it. Okay. Press the switch down. That is, and keep the sample. You got 0.651. And now let's measure the resistance between those 2 points. Taking care to put the positive there. Oh, and the negative here. Got to be careful. All right, that is positive. All right, got that. And let's see what it reads. It reads 42.9. Okay, so enter that number here, 42.9. Oh no, it didn't register. 42.9. Enter. So we got those 3 points, and you can already see the graph taking shape. So now what we got to do is we have to find the slope of this graph. Because it's a straight line, you can use the slope tool. Take this, pull it to this line, and you should get the slope. The slope is 0.019, and the slope of the voltage resistance graph should give the current. Okay, so that is what we got. Now let's check if that is the current. So that's the final thing you do. Check if that experimental current matches the measured one. Let's see that. So in order to do that, one way is you can just change this to current, and we don't need all that. Now we just, all right, press down the switch and see if the current changes. We can even remove the voltmeter. When you measure the current, you don't need the voltmeter. Okay, so I actually had to go and zero the sensor, so I'll show you how that is. Sometimes if it doesn't read, see, I go back to the settings and zero sensor now, hit OK, and then I come back, press the switch, and it shows 19.06 milliampere. If you want the current in amperes, you can just click here, and 0.019 ampere. Wow, 0.019 ampere. That's exactly the same as that you got on the experiment. See, so the measured value really agrees with the calculated value, so to say. And do not worry about this unit. It's supposed to be voltage by ohm, which is the unit of current. So that's how you do the second part. Okay, so in case 3, this is the circuit that you have to connect. You just take resistances one by one, follow the instructions as given in the manual. So you just connect one of the resistances, as you can see, and this positive is connected to SW1, and from SW2 you connect it straight to this terminal, as you can see, and then you have the ammeter here between these two. You can see the ammeter, and then the resistance is here. You just connect a single resistance, but you got to do this for a number of resistances. So you connect them one by one. So you connect the first one and then hook this wire up to the negative of the battery. So the circuit is completed. So you have the voltage sensor right here now between the ends. You're not going to change the position of the voltage sensor, nor are you going to change the position of the current sensor. What you're going to do is you're going to do this with different resistances. So after you're done with this, you will remove this resistance, put the second one in place, and so on. And then, preview again, keep the switch pressed down, and you can see the measurements of both the voltage and the current. Now what you need to do is you got to enter the value of the resistance. Only then would you get the graph there, okay? Because otherwise you would not. So you will have to manually draw this graph. So anyways, you get the voltage and the current, and you can fill it up in that table. So right now I'm talking about this table. So you put each resistance, you measure the current, you measure the voltage as given by the two sensors, then you calculate the voltage. How do you calculate the voltage? Just multiply the current with the resistance. You know the value of the resistance, so multiply these two, you would get the calculated voltage. And then you take the percentage error in voltage in each case. So you do that with 3, 4, 5, 6, about 8 resistances, different resistances. And you also can calculate the voltage from the current resistance graph. Okay? From there, you can find the percent difference between measured voltage and that found by Ohm's law, which is from here. So you can also find that. So that is in fact a very important experiment where you have 3 parts, and what you may not have understood from the video, you can understand from the manual. So use both and try to finish this lab. Thank you.